Hi, everybody. Welcome back to the Schuko Statistical Lecturing Series. And this is the practice. This is lecture number 5. We are still in the unit Introduction of Probability. So this is the second video for the lecture number 5. And we spent the first video talk about the probability postulates, the theory, and the rules. And in this video, we're going to focus on one rule. We call this the addition rule. And when we're dealing with if you have events, they are union each other's here, okay? So we're going to talk about the very basic one first, and then we're going to see what is the addition rule for the A union B. Then we're going to take a look at what is the addition rule for A union B, union C, and then how do we expand that in the general situations here. All right, so let's take a look. And those are the 5 we already talked about in our first video. So today we're going to focus on the second, the second video. We're going to focus on the addition rule. Those are the things I highlight, in the red here, right? So we did these 3 problems in the video number 1. So we're going to finish the 4, 5, 6, and the number 7 here. Okay. So now let's go back to the whiteboard and take a look at what is the addition rules here. Right. Okay. So let's take a look at the addition rules here. So for the addition rules, so basically, if you have 2 events here, right? Okay, so let's see here for the 2 events. So if I have if I want to find the probability A union B, then how do I do that? Okay, in order to do that, then let me try to, use the Venn diagram to show you. Maybe you will see, get a better idea, right? So Venn diagram, the rectangle always is the sample space. So now I have a 3 set. I have 2 sets, I'm sorry. A, so this is my A, and then this is my B's here, right? So now I'm going to I'm going to find A union B. So A union B basically is just, you combine these 2 circles together if they do have, so like I like to put on this outside here, so just show you here. If the A union B is right, so the A union B basically going to just try to find combine these 2. So you find the area of these 2 circles, kind of here. Okay, so now let's take a look here. So the formulas here, let's see here, right? So this one's here, so we said it be PA plus PB. Okay, so let's see what do we have here. Okay, PA is my purple one, right? So PA is these colors, right? So this is a PA, all right? Then plus PB, what is the PB here? PB is a green one. So this is a PB, right? So I add these 2. Whoa, did you see something here? So for the common part here, so these areas here, did you see here? This area, so this, let me see which color. Okay, so maybe I use this one. These areas here, what happens here? I add this area twice. Remember the A union B, we just want this area once and I add it twice, right? Because you see here, the green and the purple color. So that's why, and what is this areas here? This is the common areas, right? So common area we say is A intersect B. So that's why in here I need to minus A intersect B. See? Did you get that? Okay, so now that's why, let's take a look. If I have 3 events here, right? Okay, so now let's take a look at what I need to do. This one probably cannot see very clear because I'm afraid that the color we're going to kind of so mess up, so mixed together here. Okay, so let's try to do here. Let's try, maybe we can get a pretty good graph here. Okay, so here, this is my sample space. I have an A, so this is my A. Okay, now I have a B here, so this is my B. Okay, and then this is my C here. Okay, all right, okay, so now let's see the color, right? So now we say first ones here, we say is PA plus PB plus PC here, right? Okay, so PA plus PB plus PC. Let's take a look at the color. PA is here. I add this one. Okay, then PB is I add this one. All right, and the PC, yes, I add this one. I hope that's why I said kind of worried the color will mess up. So like in here, in general, if you have A, B, C, right? So if you have A, B, C, so when you union A, B, C, so what do you really care about is these areas, right? Okay, so now I have PA plus PB plus PC. Okay, so first one's here, this area, right? So this area, I want to, so this is A intersect B's area, right? So you see both. So this area, you have both the purple and the green. You minus twice. You add twice, right? So what I need to do, so I need to minus out AB. Correct? Okay, so you minus out AB. Okay, so now this one's here. So this area's here. Okay, so let's see here, this area. Okay, so this area's here, this is AC. Well, you have twice also. So what I need to do, I need to minus out what AC is here. And now let's take a look at this area. This area is here. This is BC, right? So this area is here. This is BC. And because you have the gold and the green, so what I need to do is here, I need to minus out BC. But as you see here, right? Okay, so here, the first common area, the AB, you minus out is okay. And then now in here, you minus this one out and you minus this one out. So what happens here? Did you see what happens here? That means inside this little area, so what is this little area? This little area is A intersect B intersect C. You minus one extra time, you minus too much, right? So what I need to do is here, so I need to add it back. All right, that's what is the formulas here. Now we have one, we have one homework. We're going to take a look if I have 4 events here. So now as you can see here, right? And so when you have 3 color, maybe you can still make sense of it, but you have more like 4 events, 5 events will be pretty difficult, right? So here, this is how you're going to do it, right? So if you have 3s, right? So let's put it into a group, right? So you first write each individual. Then the second one here is you minus out, right? You minus out here and here, right? So you minus out like kind of like a C32. Take 3 events, take any 2 events, right? Then here, the last group is here, you add the back, right? So you add this back. So this is kind of like a C33. So you alternate the positive, negatives here. And let's take a look in our next problems here. You will see what I mean here, right? Okay, So let's see, that's what is our addition rules, right? So addition rule is to try to find A union B. Also, like one thing here I want to mention very carefully, in the word problem, they're not going to tell you. So basically the A union B, the keyword you will see is or, right? That means A or B. So the problem, so like I said, the A or B, or you can say it here, say A or B. So A or B is really equal to the word is like either or both, right? So that means that you have so like either one or both. So that means either this one, or both, right? So that's why it's A union B here, right? Okay, so now let's take a look at our problems here, right? So the first problem, you said in the large metropolitan area, probability are 0.06, 0.35, 0.29, respectively for family or color TV, HD TV, or both, right? So what is the probability that the family own either or both? You say, oh, okay, I find this, either or both kind, right? Okay, so now let's see here. So I will say let's see. So basically, I'm looking for is what either or both. So I'm looking for this is a color. Then what is my key operations here? What is my key operation? Unions, right? So it's a union. Okay, color or HDTV. Okay, so now let's use the Venn diagram to show it. It's a typical, it's easier. Okay, so this is a color. And then here, this is HDTVs, right? From the previous video, we said we always start with the smallest part in the Venn diagram. So we can gradually just fill it in, right? So here, you see here, right? Okay, the both is 0.29. So I know this area is 0.29, correct? Right, so this area is 0.29. So the color ones here is 0.86. The whole purple circle is 0.86. This is 0.29. So what is this part here? So this is what? 0.57 here, right? So the HDTVs here, the whole thing here is 0.35. This is 0.29. So what is this part here? Is 0.06. All right. So like in here, they say, what is the probability your color or HDTV? So that's basically these two circles. So you can say this is a 0.57 plus 0.29 plus 0.06, right? By using the Venn diagram, you will see this is a 0.92. Or you can say, hey, I want to use the addition rule. Let's find this is union, right? So you can rewrite this is the probability of the color plus the probability of what? HDTV, then minus the probability of the color and, right? So and is intersections, right? Intersection of HDTV. Okay, so now you will do the color TV is what? So it's 0.86 and the plus 0.35. Then what is the both? Minus 0.29. So if you use the addition rule, you will get the same answers, right? So you don't have to draw the Venn diagram. If you use the addition rule, that will work. Okay, so now the next one here is a problem want us to write out the A union B, union C, union D to see, we know how to do it. Okay, so remember, right? So like we said here, this is A union B, union C, union D. So the first set, okay? So the first set is write out each individual. So it's A, B, C, D, right? Then the second set here, okay, so the second set here, you want to write out all the combination, right? So I have a C, I have 4 events, all the combination of the 2. then you minus it, right? You switch. So, okay, so let's see how many combinations we have. So then I need to minus A intersect B minus A intersect C minus A intersect D, then minus B intersect C minus B intersect D, and the minus C intersect D, right? So I know the second set I am going to have 6 different ways, right? So that's how do we get a second set. Okay, now I need to write out the next set. The next set here, it will be, you have C 4 of lengths. Right now you need to take the 3 events. Right now it's minus, so the next set is going to be plus. So you need to add back, right? So just like we did a 3, so you add back. So you will have here, so 4 events you take 3. So it's A intersect B intersect C plus what? A intersect B intersect D. Then plus A intersect C intersect D. Plus B intersect C intersect D, right? So that's true, that's correct, because I know the C combination 4, 3, I only have 4 different situations, right? Okay, so now I need to add back the last set here, right? So this is a minus, right? Then here, this is a plus, right? So in here, I need to go to the minus again. And this one here is C, the 4 to 4. So I only have 1 situation. So what I need to do here, so I need to minus out A intersect B, intersect C, intersect D. So as you can see, if I have 4 events, then the union formula, the addition formula, you're going to get a pretty complicated. So just remember, it's kind of like, I don't want to say it's a binomial expansion, but it's kind of like that. You start with each individual, then you take a 2, then you take a 3, then you take a 4, then you alternate the minus plus signs here. All right. Okay, now let's take a look at the next questions here. So in here we say biology has 2 assistants. The older one, the chance of the absent is 0.08, and the probability for the younger one is 0.05. Probability both of them be absent is 0.02. Okay, so like if you like, you can do a Venn diagram, all right? So this is the pink one, this is the older assistant. And then this one's here, this is the young assistant. All right, so always start with the smallest area. So both of them will be absent, 0.02. So this is the middle ones here. And then the older one is 0.08. If this section is 0.02, so what is the remaining section? Is 0.06, right? Then the younger ones here is 0.02, so this is 0.03. All right, so you can use the Venn diagram to help you, okay? Okay, so now in here, so let's say either or both. Oh, as soon as you see these terms here, that means you immediately know what I'm looking for, unions, right? Okay, so now you will say this is a probability, the older, and the union or the young will be absent, right? So let's try to use addition rule. That means it's the probability of the older will be absent plus the probability of the younger will be absent, then minus the probability of the old and the younger, right? So and, right? And it's intersection and the younger, right? So the older is what, 0.08, younger is what, 0.05. Now, what is the both? So this is the both, right? So it's 0.02. So you will get a 0.11. So if you want to just add these 3 pieces together, 0.02, 0.02, 0.03, you will get a 0.11. So it's the same things here. Okay, Now, the second part here is at least one assistant will not be absent here, right? So here I want to show you one very important. So probability at least, okay? That means more than once, right? So typical at least one, okay? So the typical at least one, okay, so at least one, in a statistic to the, it's easier to do, is that's what one of the trick. The trick here is you said at least one, so you use 1 minus probability none, right? So like if here, if you have losses here, right? So you say at least one, right? So like if this is 0, 1, 2, 3, 4 to 8, at least once, right? That means you're worried about it from here, at least one. So it's easier, just say the 1 minus none. That means 1 minus x equal to 0. Why is 1? Because the whole sample space, right? So be careful here. This is very important trick in the statistics that when you see the word at least, all right? So it's like it's 1 minus none. Okay, so let's rewrite this ones here. So probability at least 1 is not absent. Okay, so this is, be very careful how you write it. So I will say this one is equal to 1 minus, at least one not absent. So this will be probability is both going to be absent, right? Right, at least one not absent. That means at least one not absent, right? At least one not absent, see here. At least one not absent. That means could be one absent, one not absent, two not absent, or both of them not absent. So the easier way to do is to just say one minus both absent, right? Because this one's here, that means one not absent. Okay, or so at least one not absent, two not absent, right? So it will be easier to say that 1 minus both will be absent. So we already know that both are absent is what is 0.02. So it's 0.98, right? So that means 98% a chance, at least one of them will not be absent here. All right. So this is the problems, make sure you digest it and make sure you understand the wording, because a lot of those problems, they were going to use those keyword here. Okay. Okay, so now the number C is here, said only one of them going to be, the absence. So the only one. So the only one, that means I'm really is looking for which area? This area and this area. Only one, right? That means either older one or the, it's the younger, only one. So that will be what is 0.06 plus 0.03. Correct? So that's why I will give you 0.09. Okay. So when you do those type of problems, you need to be very clear about the wordings, right? They say only one. That means could be these portions, right? So it cannot include in the both, right? So that's why it's this portion one. That's why it's 0.06 plus 0.03. All right. Okay. So next problems here. This is just, this problem is kind of pretty easy. So basically, they just want to introduce you the concept of what we call this odds, right? So what is the odds here? So they want to convert the wording odds to the probability. So for example, you said that the odds for you and me to play, the odds is 2 to 1. I will win. What's that mean? The odds is 2 to 1, I'm win. That means the probability I will win is what? 2 to the 3, right? So 2 plus 1 is equal to 3. So that means that out of the 3, I have 2 odds. So it's 2 out of 3, all right? Okay, so now in here, so let's say here, if 3 eggs are randomly chosen from a carton, have 12 eggs, 3 are cracked. the odds are 34 of 21, at least one of them will be cracked. So that means basically you say the probability at least one will be cracked. Right, so here they already told you the odds. So what it will be here? So this will be 34. So this is 34 plus what? 21 here, right? It's 34 over 55. So it's like I said, it's pretty simple. And the next one's here, they said a person have $8 bills, $5 bill, and one $20 bill. If I randomly select up the three, find and the odds is 11 to 2. Right, so the odds is 11 to 2. Let the bill will not be $1, right? So that means the probability is not the $1 bill. So the probability is not the $1 bill. What is that one will be? So this one will be what? So it's 11. And so this is 11 plus 2. So this is 11 over 13. Okay? So now the part C is here. We say if we randomly arrange the word next, the odds are finite to 1 will not get a meaningful English. So basically we are saying, okay, so probability, we go to get a not a meaningful. That will be what? 5 to 1, right? So it's 5 plus 1, the 5. So it's 5 over 6. Right, so if the problem asks you what is the probability you will get a meaningful word, so what it will be? 1 over 6, right? Not meaningful is 5 over 6, and so meaningful is 1 over 6. And that's it. All right, so for this video, the key focus is the addition rules, right? So it's A union B. Remember, in the word problems, most likely the problem will not tell you, say, hey, find the probability of A union B. So in order to find the keyword here, the keyword for the unions, right, for the addition rule, typical the keyword is or, right? Okay, so or you can set it either or both, right? And then also we learned the one trick here is a probability at least. So at least 1, you can use the probability is 1 minus none, right? So those are the two kind of important things. Like I said, they're not going to ask you, so tell you to find a union or intersection. So you need to understand the keyword to find. Okay, that's it. Okay, so if you like the video, don't forget to subscribe it. And if you have questions, feel free to leave me a comment and I will answer your questions here. It is so nice to talk to you, and we finished this lecture. Our next lecture is even have more fun. So we're going to talk about the conditional probabilities here. Okay, and so now you have a good day, and nice to talk to you, and looking forward to talk to you again into our next lecture. Is we're going to talk about the conditional probability. Okay, bye. Have a good day.